Hello everyone, let us study biostatistics today. Let's ask the first question. What is biostatistics? And the answer to this question is very simple. It is the tools of statistics that are applied to the data that is derived from biological sciences. What is the data derived from biological sciences? Is the data that is obtained through experimental research, the data that is available to us from medical sciences. And the question that needs to be asked is, what is statistics? Statistics is the field of sciences that is concerned with the techniques of collection of data, classification of data, summarization of data, and representation of data. This is also sometimes called as descriptive statistics. The other form of statistics is inferential statistics. And what is inferential statistics? It is the data that is collected. We have interpretation of that data. We're going to draw inferences from the given data and to carry out hypothesis testing based on the data and make recommendations at the end of the study. There are some more definitions which we should know before we go further. These definitions are variable. Variable is X. It is the characteristic that takes different value. It is the point which we are studying. Then what is observation? Observation is the data which we collect from an individual. And therefore, what is an observational unit? It is a source that provides the observation is called as an observational unit. So therefore, what I'm trying to say is an observational unit is an individual. Say for example, we are discussing height. So every individual would be the observational unit. The height that is measured is the observation, and the variable out here is the unit that is measured. In an example, for example of height would be height measured in centimeters, and the height that is observed as a value is the variable which we have. So therefore, what is data? Data is all the set of values that we have recorded from the different observational units. What is a population? Population is all the data points possible for the given set of observations. Therefore, a corollary would be sample. And what is a sample? Sample is a subset of a population or a part of population, and it represents the population. To study further, let us also discuss some more definitions which we require for the current study. Quantitative data. Now, data which has units which can be measured is quantitative data. Okay, so the point I'm trying to make is it is a measurable data set, that is a quantitative data, and therefore a corollary to quantitative data is qualitative data, and the variable in this case cannot be measured by a normal scale. It has different attributes, and a parameter would be the descriptive value that describes the population, and a sample would be described using a statistic. We need to remember some important notations before we go further. We are going to study different descriptive factors. For example, mean is denoted as an X bar for a sample and mu for a population. Similarly, standard deviation is denoted as SD for a sample and sigma for a population. Let us go to the crux of today's study, that is descriptive statistics. We are going to learn to measure the parameters or statistic. So before I go further, let me discuss grouped and ungrouped data. Now, what is ungrouped data? Is when you go on collecting data one at a time in its raw state, unprocessed state. The data that is available is ungrouped data. We can further classify this data and get a grouped data set. A grouped data set is commonly done when the data readings are large in number. With that in mind, let's go further and study descriptive factors. Now, descriptive factors are processed in two types. The first is the measure of location, that is, measure of central tendency, the values that take you to the values which are maximum in number or the values which are at the center of the data set. The examples of central tendency are mean, median, mode. As similar to the measure of central tendency, there is something called as measure of distribution. This would be how the data is separated or distributed across the entire data set or entire set of values. The examples for this are range, interquartile range, and standard error. We will study standard error in detail in further chapters. In this chapter, we will be studying variance, standard deviation, mean deviation, and coefficient of variation. Mean deviation is not commonly studied. A very critical factor which is very important for describing data is standard deviation. Rather, the critical descriptive factors that are essential to describe the data set are mean and standard deviation. Let's go further. Let's take up an example of ungrouped data for a population. The question says erythrocyte sedimentation rate of 7 suspects of a certain disease were studied and the data was found as follows. Now what we have is there are 7 set of readings which we have obtained from 7 subjects and we have got different erythrocyte sedimentation rate. We are supposed to calculate the mean, median, mode, sum of squares, variance and standard deviation and coefficient of variation. So let's start solving this problem. Now, we know the definition of mean. Mean is equal to the sum of observation values divided by the total number of observation. Mean gives you a central value in the data set and it is denoted as, for a population, mu is equal to summation of x, that is sum of all 7 values divided by the total number of values. And in this case, if we write down all the values and we add all the values and we divide it by the total number of values, that is 7, we will get the mean as 34 divided by 7, which is equal to 4.86, and therefore the mean is 4.86 units of erythrocyte sedimentation rate. This is fairly simple. Let's go ahead. Median is that observational value of the observational unit that divides the data in 2 equal parts when it is arranged in an ascending or a descending order. In this case, the data has odd number of readings, that is 7. We have to remember that the median is calculated by n plus 1 by 2 value. That means that observational value, which is n plus 1 by 2. We will have to arrange our data in an ascending order or a descending order first. Let's, in this case, arrange the data in ascending order. Now, the median is the value which is n plus 1 by 2, which is 7 plus 1 by 2, that is the 4th observational value, and in this case 5 is the 4th observational value, and therefore the median is 5 units of ESR. Now median therefore will divide the data set in 2 equal halves, while mean is the positional midpoint of the entire data set. Now let's discuss about the mode. And mode is very simple. Mode is that value which is repeated maximum number of times in the data set. And in this case, number 4 and number 5 is repeated twice, and therefore the mode in this case is 4 and 5. Yes, data can be 2 modes, and in this case this is a bimodal data set. That means it has 2 modes. We would have further examples where we might have a single mode, or it could have multi-mode. That means it can contain 3 or more modal values. With this, we have finished measuring the central tendency, and now we need to measure the dispersion. Now, measures of dispersion would be deviation from the mean value which we are studying today. And for that, we would be having sum of squares, which is nothing but summation of the square deviation. We will discuss what it is exactly in few minutes. We have variance, which is the mean sum of squares, and standard deviation is the square root of the mean sum of squares. We'll discuss them in detail shortly. Let's first discuss sum of squares. Before that, we need to calculate the measure of dispersion, and we will calculate with the current data set. We'll have to first create a table. In that, we'll have to first mention all our values of x. These are the 7 values of x which we have got. Then what we have to do? We have to measure the dispersion, and for that we have to measure the dispersion from the mean value. And in this case the mean is 4.86. Alright, so we just note down 4.86 as the mean value for all of the data set. Now we have to measure the difference of the value of x from the mean. This is nothing but 7 minus 4.86, which is 2.14. Similarly, we carry out for all set of readings. Don't worry about the negative values at this moment, because they will be taken care of shortly. We have to square these values. Now, if we add all the values of x minus mu, we would get it as 0.02. This value is nothing but sum of deviation. And if we take a mean of this, that means we divide minus 0.02 divided by 7, we would get a mean deviation. But however, as I have told you before, mean deviation is not commonly considered. The commonly considered value is standard deviation, and we will go to it shortly. For that, we need to square. We need to square the deviation, and therefore we do x minus mu the whole square. So we need to square 2.14, and we get as 4.5796. Similarly, we carry out the function for all the values, and we would get the following readings. When we add all the values from 4.5796 to 0.0196, we get 10.8572. This is sum of squares. Now, sum of squares can be denoted by the formula SS is equal to summation of x minus mu the whole square. As we have done before, this value is 10.86 units of ESR. Now, the point to be noted out here is the units are squared. From sum of squares, we can study variance. And variance is the mean of sum of squares. And how do we get mean of sum of squares? We divide it by n. And that is the formula. Variance is denoted as sigma square is equal to x minus mu the whole square, that is sum of squares, divided by n, that is the total number of values. In this case, we can therefore write it down as 10.86 divided by 7. Therefore, the variance is 1.551. Point to be noted out here is variance is the units squared. The next step is to calculate standard deviation, and standard deviation is the square root of mean sum of squares. Therefore, we take the entire function and get the square root of it, and we would get the value to be 1.2454. and therefore the standard deviation is 1.25 units. Point to be noted is mean and standard deviation has the same units as x. Therefore, the steps in calculation of standard deviation is as follows. First, we calculate the mean. Then we subtract each value of x from the mean to get deviation. We square each value of the deviation to get squared deviation, and then we add all the squared deviation values to get sum of squares. We divide the sum of squares by the total number of observations to get mean squared deviation. This is called as variance. And the final step is to get square root of the variance to get root mean squared deviation. That is nothing but standard deviation. These are 6 important steps while calculating standard deviation. Let's discuss the last type of measure of dispersion, that is coefficient of variation, which is nothing but standard deviation represented as a percentage of mean. Therefore, the formula for coefficient of variation is given as standard deviation divided by mean into 100. In this case, if you put in the values which we have got, that is 1.24, that is the standard deviation, divided by 4.86, that is our mean, into 100, we get it as 25.63, and therefore the CV is 25.63%. The point to be noted is CV is measured as percentage. Thus, for the given problem, the descriptive factors are the mean is 4.86 ESR units, median is 5 ESR units, modal value is 4 and 5 units, variance is 1.55 units squared, standard deviation is 1.25 units, and coefficient of variation is 25.63%. Where do we measure coefficient of variation? We measure coefficient of variation when we have a data set which is different from each other. However, the variable that needs to be measured is the same. And therefore, we can compare two different data sets for their variation, provided that the variable is the same. Thank you very much. If you have any doubts, you can always ask me back on abhishek.chaya@somaya.edu.